Okay, so this week's speaker is Tim Eddy, and I've known Tim for a while because he is actually a Sooner, got his undergrad at the University of Oklahoma, and he's now a PhD student in systems engineering at University of Virginia, working with Jim Lambert, and he's going to be talking about some transportation risk analysis stuff today. So please, Tim, go ahead.
All right, so thank you for the introduction. I'll be talking about intermodal transportation risk filtering. So looking at infrastructure investment from a government perspective and how they might look at the potential risks of moving beyond a siloed one mode approach, right? So traditionally, you'll have a Department of Transportation that focuses solely on highway. Depending on where you are, you might have a port authority or a state port authority. And some states do, some don't have a separate rail department, some have none whatsoever. So there has been an increase from departments of transportation, traditionally focused only on highway, to now look at investments in other modes, recognizing potentially an improvement in rail or port flows could actually decrease the amount of money they have to spend on highway maintenance. So that's the brief setup, but what we'll go through is first we'll talk about motivation, right? So expanding on what I was just discussing. I'll give you an overview of what the model does. There's 2 case studies, and then of course discussing the results from those studies. All right, so rail is a cheaper method for shippers, right? The cost per ton mile is lower. It has fewer emissions. It has lower environmental impact. It also takes trucks, semi-trucks off of the highway, which is the main benefit to, or one of the main benefits to departments of transportation, right? Because these big heavy trucks are the greatest source of wear, far more than passenger vehicles on the highway system. So if they can divert the metric is 20-foot equivalents, right? 20-foot being roughly a trailer load. The number of 20-foot equivalents they can divert from highway over to rail will decrease their maintenance budget, right? So there's an initial investment and a long-term return. One of the key hang-ups is that highways are public and rails are private, so you're spending government money on what is a private asset. There is a history of it in the United States anyway. The rail was originally developed or funded entirely by the federal government post or during Reconstruction. But since then, there's been decreasing appetite in spending public money on that. So the DOT, at least in Virginia, and I would suspect most places, considers that somewhat increased risk politically, because you're spending the money in a place that's not as traditionally supportive of it. So the expectation for recognizing how likely it is to work in terms of diverting trucks off the road is higher. So there's a higher standard of evidence. There's also implications for ports, as I mentioned at the beginning, that many of the bulk shipments would preferably go by rail. And historically, that has been constrained. So if you look at a great example of that would be the port of Philadelphia back in, I believe it was the 80s. It was either 80s or late 70s. They invested heavily in rail, and their port went from nearing closure to becoming a booming port. So there is significant potential for these intermodal impacts. So this is a little bit specific to where I studied, right? But in Virginia, the rail is essentially at capacity along 2 of the main rail corridors. And in terms of what's coming in through the port is going up, right? So there's increasing demand and minimal ability to meet that demand. So fairly basically, that results in more rigid decisions on the part of the shippers. They have no choice. They essentially are forced into using highway for commodities that may not be conducive to that. So rather than make a economically poor choice, they just won't bring it through. It'll either not be imported at all, or it'll be imported through a different port. So one of the key steps in this model is, we're interested in diverting shipments from highway to rail. So you have to know under what conditions could that happen, right? And Federal Highway Administration has done quite a bit of work on this, but there's this key gap in work that has been done, on the cutting edge, at least the cutting edge at the beginning of this project. And the advancements have there have not been many advancements since 2018 either. So what has traditionally been done, decades, is a 4-step model of demand, right? So you estimate how many trucks are going to go from point A to point B, and then you estimate if they're going to go on highway or rail, and then you get an estimate of demand, right? So that is the traditional 4-step model, and that is considered wholly inadequate, or has been demonstrated to be wholly inadequate for this type of a problem. Now, right, so that's arguing for a more complex model than has been used before. But on the other hand, the gold standard that has been developed is something that costs tens of millions of dollars to implement over 4 to 5 years, which is I'm not arguing against that, but it isn't appropriate for a initial filtering of which projects should we spend the money to model in that way. Additionally, that 4 or 5 year delay can be entirely catastrophic in terms of actually seeking or experiencing the benefits you're expecting, right? So there needs to be some kind of happy medium between these two points that the literature has settled on. Right, so this brings in the idea of risk filtering. This little chart on the side is from a paper. It's just, I don't, explaining what these bi-criteria filtering is, right? So any potential project, which there will be hundreds every year, will get fit into each one of these little boxes, and the ones in the top right are most concerning because it's most likely you'll get the outcome, and that outcome is the most extreme. Right, so that's the theoretical foundation behind the concept. But essentially what this is doing is, past work has always focused on using a transportation model to create trip generation. Right, and what we're moving to with this methodology is, rather than identifying or estimating, defining trip generation, we're looking at exposure to modal shifts. Right, so what is the greatest potential for modality shift to occur? How likely is it? And the composite of that is used to filter out projects that are not even remotely possible, the ones that are most promising, and moving on then to these more advanced, multi-million-dollar, potentially years-long development projects, right? Which you can't exert, or you can't apply those resources to every project, so you do have to filter in some manner. And right now, there's no systemic way to do it, which is the benefit of this method. All right, so just distilling that all down into one research question before we move on to the model. Where can infrastructure investments enable what an economist would consider rational movement of goods? Right? So useful to break that down as simple as it can be, and then we'll go into the model. Right, so we'll talk a little bit more when we get into the specific case, but the Virginia Planning Research Advisory Council initiated this project, and they were interested in 3 specific things in terms of estimating diversion. They wanted to know which products can be diverted, how far do they have to go before it's feasible, and doesn't matter how quick the shipment needs to happen. Now, I put this in as background because it is involved in the first case study, but you'll see it in the second case study. It's found that this isn't a terribly useful framework to analyze this problem, but it was the starting point, so it's useful to understand where it came from. So here's the resulting, in a broad stroke methodology of the model. You start in the top left with a modal assignment, right? I have a shipment, say, of logs going from the Port of Virginia to Oklahoma City. I don't know why anybody would ship it that distance, but maybe that's something that's going to happen. So the modal assignment model is useful to understand, well, would that be better, more logical, more economically efficient to do by rail or truck, or barge isn't relevant for that particular route, but in some cases barges are a relevant mode. So you use that modal assignment model, and then you use a registry of all flows that have occurred to develop an efficient market structure, right? So in an ideal world where there's no contract inefficiencies, no distortion in the market due to large corporate deals or infrastructure snaggles anywhere along the route, any of these confounding factors, which I'll list on the next slide. If none of those existed, you would have a perfect ideal market. So that's the efficient market structure step in the model. And then the final step is to compare those two, and which gives you a market risk model, right? So where is the gap between a theoretical perfect market and reality? And that is an estimate of your exposure. And then combining that with the modal assignment, you get an estimate of the probability, which composites together to your risk. So the confounding factors that I talked about in that second step in terms of why is the market not perfectly efficient. The two main drivers are cost and service, which is somewhat easy to capture in the data. But what confounds it are things like visibility, right? So if you ship something on truck, in the last few years, it's become possible for you to track the entire route where your product is, or at least on certain waypoints. With rail, that has been a much more recent advancement and is still far less detailed. Risk elimination, right? So there's some increase in probability of your shipment, ending up on the side of the road as opposed to a train derailing. However, if a train derails, you have a larger quantity that was lost. And specialization, right? So if you are shipping something like live animals, there's highway methods that are highway modalities that are specialized to that, and it's not going to go on to rail, regardless of cost or service. There's regulatory changes, right? The size of the trucks, the weight of the rail cars, they can lead to changes, and of course diesel price, which because rail is more expensive or uses less diesel, it's less sensitive to that. And the rail network is uniquely sensitive to increases in demand. If demand goes beyond a certain level, service speed drops quite quickly. All right. So the key data set was FAF, which is the Freight Analysis Framework. It's collected by the Federal Highway Administration. And I'll get into detail of what that data set gives on a future slide. GIS came from, that's the Department of Rail and Public Transportation. So Virginia has a specific agency dedicated to rail, and they collect GIS data. In terms of cost, that came from the American Transportation Research Institute, which is a industry group, and as well as what they call them tariff sheets coming from regional railroads. So that gives us some insight into cost. So this is an example of what a few rows of that FAF data set have. There's other attributes, but these are the ones that are most useful. Essentially, where it came from, where it's going, what it is, how it got there in terms of mode, truck, rail, air, whatever. how many tons of product was moved, and what its value was, and what the distance that it moved was. The most recent data comes from 2018. We should get 2019 in December if the pattern holds. So one of the shortcomings, and it's not dramatic, is with FAF is that this map here highlights 4 different regions for the entire state of Virginia. There are a few hundred for the entire country, so it isn't exceptionally granular, right? There's no the entire western portion of that state is one block as far as this data set is concerned, but in broader infrastructure terms, it's not that terrible when you actually look at how these policies, how infrastructure would be designed, because we'll talk about one of the case studies in the end, and you'll see that it's almost entirely contained, even though that region is very large. So here's the market risk model, which is that last step in that methodology. So the bottom is I used the format of a confusion matrix just because it's probably useful for this audience. But when I say mismatch, I'm talking about, the modal assignment or the perfectly efficient market, something would move by rail. In reality, it moved by truck or the reverse. So that would be a mismatch. An efficient flow is where those two models produce this, or when the model reflects reality, or reality reflects the perfect market. That's an efficient flow. Right, so case studies, which are that left column, is a hypothetical project, right? So we'll get into 2 case studies, but one of them is to do a major rail investment. So when you consider what the changes that would occur and how the market flows would change, you then get these case study flows. The current flows on the top row are just the current state. So if something is happening inefficiently in both the case study and in the current state, it depends on the magnitude whether or not that is something you should look at, right? So if the mismatch went down in your case study, then maybe you consider it. If it went up, you obviously don't, right? As opposed to if the current flow is inefficient and you predict the hypothetical case study flow would be better, then that is filtered, that is kept, or not filtered out, right? So it's a project that should go under consideration. And it's probably self-explanatory what the other 2 are. So this is the first case study. It's I-81, as I mentioned, with those FAF regions almost entirely contained. So that's why, at least in transportation, it's generally not a terrible data set, even though it isn't extremely granular. Let's see. The initial commodity that I used was wood, and then derivative products of wood, because that one has high flexibility between rail and highway, right? You can easily put logs on a rail truck because they're heavy and there's a lot of them. On the other hand, you do see that they are on the highway quite a lot as well, because many of the places they're coming from or going to do not have rail access. So there is significant flexibility. It's also fairly highly ranked in terms of import and export. So that was the first case study. We'll go into results at the end. The second case study is a comparison of 2 of the eastern ports. It looks at all the imports to those ports from anywhere in the world to anywhere within the United States, and there's no commodity filter. And this is mixing stages a little bit, but the reason that it flipped to all commodities in all regions is because the initial case study, the magnitudes were so low that it was obvious you can't restrict just to certain commodities. Right, so this is from that commodity-specific analysis. Right, there is no feasible range, right? Because I-81 is roughly 400 miles, which give or take is the cutoff for putting something from highway onto rail. So there were no projects, there were no potential flows that were in that bottom left quadrant where you would consider them in an unqualified manner for further analysis. So what that points to is, because we know that distance was the shortcoming, that points to the need for a multi-state cooperative, right? Because that the flow along that highway goes essentially from Florida to New York City, right? So any combination of states along that corridor, as long as it's contiguous, could result in beneficial flows. But in terms of a single state taking action, it would not be a feasible method. Which, even though that is a null result, it was important for the state, because that was one of the that is one of the most hotly investigated potential projects. Yeah, here are results. Once you remove the commodity flows and you're looking at the imports of two ports. So there's roughly 400 flows going to 66 destinations. And these are the 9 largest in magnitude, right? So the scale on the left is thousands of tons. So we are talking about quite large volume of product. And, obviously the taller bars are the ones that are more, have more exposure to infrastructure risk. So the DC area is a hot spot based on this analysis in terms of rail constraining the flow of goods into the United States, at least from these 2 ports. All right. I am happy to take any questions anybody might have.
Excellent. Any questions for Tim? So you said this was funded by, what, with VDOT or?
So that first case study was yes by it was directed by VDOT. It was funded indirectly by the university, and then the continuing research, I'm funded by a GAN fellowship through the Department of Education. So they, I guess technically would be the sponsor of it. Gotcha. Though the parties that use it are the DOT, Department of Rail, and Port of Virginia.
Okay. Other questions for Tim? So you're in, oh, wow.
Tomatoes and peppers, but I appreciate the question.
Oh, man. He was always an entrepreneurial student. So.
Yes.
That's amazing.
Mm-hmm.
In this is your second year as a PhD student?
End of my first year.
In your first, okay.
I finished my master's last August. So.
Yeah. Okay. Gotcha. And so, I guess initial work here has been published somewhere.
Yeah, it's submitted to SRA.
Gotcha. Okay. All right. Well, if we don't have any more questions, man, I know Tim is itching to answer something. His green thumb abilities. But okay, well, thanks so much, Tim. And next week we have Purya from Stevens Institute of Technology. and every Wednesday after that until early August. So keep coming back and encouraging your classmates and colleagues to join us. And so I guess we'll see you all next Wednesday.
Thank you.